Hello everybody. Welcome to our talk about running Shopware in a highly available distributed setup. My name is Patrick Derks. I'm a principal software engineer at Shopware. I started 5 years ago in the SaaS team. Then 2 years ago with the start of PaaS, I also joined there. Currently, we are the maintainer of the operator and the Helm chart. You can reach out to me on GitHub or also on LinkedIn. There's also our community Discord. I barely look into this, but if there's Kubernetes questions, there are some colleagues which ping me, and then I can also answer that. And now to my colleague Tim.
Thank you, Patrick. So, hi everyone. Nice to see you all here in the talk, and the room is almost full. Thank you for coming. I'm Tim. I'm senior platform engineer, as Niklas already said. I'm working for Shopware now around 5 years. Started in the Shopware business platform team, and now since beginning of the year, I've joined the Shopware PaaS team. So I'm mainly responsible for our infrastructure, our API, and our Shopware PaaS CLI itself. So you can find me as well as Patrick on GitHub and on LinkedIn. So if we want to connect, you can send me a request. So first of all, before we start, I have some questions to you. So please raise your hands if this question applies to you. First one. Is any one of you hosting a Shopware store? Please raise your hands. Oh, perfect. Many hosters? Hosters? Okay, perfect. Is any one of you using Docker for hosting? Okay, less hands. Is any one of you using scalable services like caching or databases? AWS, anyone? Perfect. Okay, is any one of you using a shared object storage like S3? Okay, I would wonder if it's not the case. Okay, is any one of you using Kubernetes? My absolutely favorite question. Okay, really more than I expected, and as well Patrick, I think. Okay, now before we come to our experience of running Shopware in a distributed environment, as we heard, which is our talk about, we will dive very shortly into running Shopware on-prem. So first of all, we need a web server. In our case, it's a really old one, it's Apache. Okay. The another part is a database. In our case, we used MariaDB, and this is supported besides MySQL. Then, if we want to extend the caching functionalities of Shopware itself, then we will use a Redis. And last but not least, if we do not want to use the database itself as a queue, then we extend it with RabbitMQ. And of course, you can switch out every component as you want and what fits your requirements best. Okay, now we know what we need to host Shopware on-prem. And now we dive into what we need to host it in a modern infrastructure. Okay, the answer is containers. Our Kubernetes guys here in the audience will know why. I will tell you some important parts why they are necessary for us. And first of all, containers can handle deployments at scale at the best. So why is that the case? We are able, with containers, to capture our code and our dependencies in one deployable unit. So we do not have to care about, is the correct version of my service or dependency installed on my server, or is it installed in general? The container can handle it itself. So the build process will ensure that we have all necessary dependencies in our container. So we basically define a blueprint where we say we need this and this and this, and our build process will do it for us. And at the end, we will get a container image. With this container image, we are able to reproduce behavior with our code. Okay, the next part is isolation. With containers, we are able to isolate them if they're running on the same server. It's also possible to configure them to run in a secure way. For example, using a least privileged user instead of the root one, do not give your containers root level access. So the isolation can be also made on another level. For example, memory, CPU, or networking or I/O. And this is possible due to the Linux kernel. The kernel itself has a mechanism which is called cgroups. With cgroups, I will only dive into it shortly because it's a very huge topic. With cgroups, we are able to limit the process itself. And for example, we want to limit our process with 1 GB of RAM. Then we set the limit, and the kernel itself will automatically kill my process if the 1 GB of RAM will exceed. And of course, there are many more things we can do with cgroups, but as I said, it's too much for the talk. Okay, the next part is we can predict our rollouts. So as I already said before, the code is one deployable unit. Therefore, it makes the rollout process more reliable and predictable. All these parts are the base for automated workflows. For example, rollout, testing, development. Shopware already provides a base image for us, where we have some dependencies installed, for example, Caddy, as a web server, and so on. And I've linked it here for you. So if you want, you can check it out on GitHub. It's open source in our repository, and you can use it if you want. Okay. Now we heard in the slides before, running Shopware on-prem, why containers are our friends, and why do we need them to run in a modern infrastructure. And now I will want to talk with you about why we choose Kubernetes in Shopware PaaS. First of all, the first point is scaling. Scaling can go in multiple directions. I will start with the first point, multi-node cluster. It's a really, really fancy wording, but simply said, we are able to scale our infrastructure. So, for example, if we need more capacity in CPU or memory, then we can simply add new nodes and spread our workflows on the new nodes. And in Shopware PaaS, we're using AWS to host our completely infrastructure. And we can provision or remove AWS instances if we need them. We automated this process in our infrastructure with a controller, which is called Carpenter. Carpenter observes the CPU and memory usage of our applications and of our nodes. So we can therefore optimize the resource usage automatically as efficient as possible, because we can scale down and scale up as we want. And to make this a bit more cheaper, our AWS guys here in the room will know on-demand instances can be very, very heavy in the pricing. We are using AWS Spot instances. That they are basically resources that are not used by AWS, and we can get them for a cheaper price. But there's a little downside. We have a 2-minute window where AWS can reclaim our node. So that means we have 2 minutes time at any. We don't know when this will happen. AWS can reclaim the instance within a 2-minute notice. So it's a way too short time to react manually. Therefore, Carpenter also handles this for us by provisioning replacement nodes. So Kubernetes then can rescale the workloads on the new node. Okay, this whole process can help us in the following situation I want to explain to you. We had a node where the kubelet on our, we had a scenario where the kubelet on one of our nodes are died. So because of too much memory usage of our applications, and also the kubelet itself didn't reserve enough memory for the process itself. The kubelet is responsible for the containers on the node and to communicate with the kube API. And therefore, it's normally not a problem, because we can easily replace the node and move it to another one, the workloads to another one. But we had the case that on this node, we're running in Valkey. Valkey is the new new product. It's from branch from Redis, and it's also usable with Shopware. So it's for caching, basically. And Valkey had a volume attached to the node, which we called zombie node. So the whole node was not reacting anymore, and we were not able to reschedule Valkey itself, because our EBS volume controller, we are not able to detach the volumes from the node. So it means the state of the Valkey was saved on the volume itself. And therefore, we had a store which was connected to the Valkey. We're down. So we had a downtime of around 5 minutes. In this 5 minutes, the EBS controller was able to reattach the volume on another node, detach it on the old node and reattach it on the new one. Okay, that's a pretty shitty behavior. And we decided after this situation to use Valkey Sentinel. Valkey Sentinel provides us clustering features and failover features. Okay, long story short, the next point, deployments. Many of you know that deployments are very, very powerful in Kubernetes, but I will only pick one part of it. So with deployments, we are able to tell Kubernetes how our application should look like in the infrastructure. So how many replicas do we need? How many volumes do we need? How many resources do we need for the application, and so on. So in our example, I will pick how much instances of my application would I have. So for example, 10 replicas means I will have 10 instances of my application. And I tell this Kubernetes due to the deployment, and Kubernetes does it for me. It will take care of it. Okay, now we can, with deployments, we can do it manually, but we want it automated. And now we are able to automate this process, for example, by collecting PHP FPM metrics of the web server and scale the storefront, for example. So this makes it possible to react fast on increasing traffic, for example. Okay, just to summarize it, a container in Kubernetes can die at every time, and also a node can die at every time. We have absolutely no control over it. We can design our system for it, but we do not need design around it. So that means we need to configure Kubernetes correctly to make this failover behaviors reliable. So it's, yeah. So the next part is it will ensure that your apps run without any interruptions for the outside world, resilience. So the first point is Kubernetes has for this built-in health checks. These health checks will ensure that your application is in a healthy state. If it's not anymore, then Kubernetes will automatically kill your application and respawn a new one. So it tries every time to ensure that you have the replica count you configured. So this also, the health checks also ensuring during deployment phases that Kubernetes will, running the old version of your application and rolling out the new version, and ensures that your new version will healthy before killing the old version. So only at this point, if Kubernetes is sure about that your application is healthy, it will automatically shift the traffic to the new version of the application. Of course, you can configure this behavior as you want and as you need, but yeah. So This will ensure that your application will be reachable during the rollout process. Okay, the next part is declarative configuration. Kubernetes is designed based on the desired state pattern. That means you define what you want and Kubernetes does it for you. So as we already heard, for example, the amount of replicas, or that we need a volume attached, for example, to the container, Kubernetes will ensure that it is. We need to say, do it. And the next part is distributing your application across nodes. So remember the example of the zombie node we had? And we are able to spread multiple applications across multiple nodes. So we are able to make therefore, the applications more resilient. So, for example, we can tell Kubernetes with a spread constraint, please ensure that not the same application is on the same node. Yeah? If the node will be killed for whatever reason, we will have another applications running on another node. Okay. Just to summarize this. Kubernetes can ship the resilience, but you still own the failure case. With you, I mean us as an infrastructure engineer, we need to configure it correctly. You need to declare and configure it as you need. Otherwise, Kubernetes will use some default values, which are, of course, not really production ready. It depends on the case. So prepare your cases and apply the config for it. Okay, and I think I have talked enough and will hand over to my colleague Patrick. He will tell you something about the operator.
Yeah, thank you, Tim. So also the operator pattern is like a really strong pattern. It brings resources into desired state, which is already built in Kubernetes. You can also write your own custom logic to it, and there's like some reasons why you shouldn't and why you should maybe. For example, if you have like a custom lifecycle. So this means if you, for example, have here a Shopware image and you want to change, like swap out the image, there's mostly you need to do like some migrations. Sometimes there's like SQL migrations. So you need to start like a pod, like a container, and something needs to happen. This state, after this is done, then it swaps like out the image. This is some like custom logic what we can use. Also, if you have, like, for example, a disaster recovery state, so you're like updating it, and there's like problems you want to roll back, this can also be done inside your custom application lifecycle. So this is like a good reason to do this. There's also like custom application status, so it's like a representation of your store, basically. So here we have like the admin state, worker state, and the storefront state. Currently, nothing is running, which is not good. But we are currently waiting. This is the state. And there's also a message, but I like cropped it because of like scaling reasons, which telling you, hey, your S3 is like not ready. That's basically it. There's also the state is swapped out to migrating if we do like the swap out with the image. So if you swap out the image, then you have like the state migrating. And there's like also message if something is like happening or stuff, like if something goes wrong. Also, which is really powerful, you can interact with your application directly. So Shopware has an API. So we can, like from the operator itself, we can talk to the API, which is, currently we don't do this. But if you imagine you have also the database credentials in the operator itself, so what we can do, we can modify the database. And if you think of the desired state pattern, you have like an admin password for your administration. And if you give customers the ability to log in as admin, they will maybe change the password. Happened to us like not only once. And the operator makes sure that like every 5 minutes it's recompiling, checks, hey, what is the state in the database? Hey, this is a different password, I will reset it. So you have your desired state, and the operator makes sure to apply this. So to summarize, this is like really powerful. It makes like sense, and if you have like a custom application. But there's also like some downsides. You should not use it to make like everything with it. Like, don't use it to deploy like third-party services like S3 or like databases. This will bloat it up, and therefore, for us, it would not work, because then we can also not open source it. Yeah, these are the main 3 reasons why we use Kubernetes, or why we choose it. And now, what else do we need besides Kubernetes? There must be, like, at some points, bindings to Shopware directly itself. So we have like a Symfony recipe, which is in our name, or we called it like Kate as meta package. So you install it with Composer, and this is like the binding between Shopware Operator and your Shopware configuration. So for example, you have like a Redis URL, which is coming from the operator, and then brings it over as an environment variable, and then it's just like configuration. Shopware reads it out, and then it's done. So nothing special there. We have also the deployment helper. This is a separated PHP tool, which brings Shopware into a desired state, kind of. And it's also like idempotent, so you can run it multiple times without. You can like run it multiple times, but it only will change it one time. More details about this at Zona's talk, I think also at the tech stage today, and it's called like Boost Your Dev Pipeline. Should be at 16:45, if I read it correctly. The Shopware Operator used the deployment helper in the setup and in the migration step, but it's also used on-prem, and that was also the first goal of it. So this is mostly for on-prem, and also like for hosters. It makes like life easier. Like, as I said, more information later on. So yeah, now to the evolution of our technical landscape, which is maybe a bit interesting. So we never used Apache Web Server. We like directly go to Caddy and Docker. Then we had like Redis running until they changed the licensing. I think some of you heard of this. So we started to use Velky as a dropped-in replacement, and so far, like, we had problems with it, but yeah, later on. Also MariaDB, we never hosted our database. Like, we never hosted MariaDB directly. We jumped to Percona, which is like, if you search Kubernetes, like MySQL databases in Kubernetes, you will find Percona. We use this. They are also like open source. This is also like the default in our Helm chart. So if you use our Helm chart to install Shop, then you get like a Percona database out of the box. RabbitMQ also, most hosters will like say, hey, this is like a not really painful service. It just runs without any problems. We tested it out in Kubernetes, and like it was like 2 years ago, but it was a bit pain with the operator. So there was like, hey, this was not so stable as we wish. So we tried out Velky Stream, and it was working without any problems. So we said like, hey, let's deal with this. And since we already have Velky for session cache and app cache, we said like, hey, let's stick with this. No problems at all so far. Yeah, as Tim mentioned, we had the problem with Velky where like the node was dying, and then the session cache was like more than 5 minutes away, which is you don't really want to do or deal with this stuff. This was only a problem because the zombie node went like away, because we already use the soft purge from AWS. So like the node is like each day we have like 3 nodes like get switched out. This is like no issue at all. But if the zombie is like away and it's not responding anymore, we had like problems. This is where we choose like Velky Sentinel, which is basically a high availability service for Velky. And also no issues. Yeah, Percona, we dropped it out with AWS RDS, caused some discussions, but this is like doing for like limited capabilities in our team. We're like only 5 people, engineers, and we are like no database experts, so we didn't want to host our database inside Kubernetes. And we use AWS RDS already in SaaS without any issues. And like we have already experience with it, so we decided we use AWS RDS. Our Grafana stack. It's a bit bloated. We use Loki for logs, Thanos for metrics, and Tempo and OpenTelemetry for tracing. I think like tracing is really powerful because I think it was last week, there was like a customer say like, hey, there's like 12 seconds HTTP call, which is quite slow. And yeah, that should not happen. Let's see. We go into tracing together because our customers can go into the Grafana stack. And we showed them, hey, there's like this database query with some joins in it. And we also can see that this was from a plugin vendor. So we said like, hey, everything else is like really fast, and also the database is really fast. There's like no issues with it. You should reach out to the plugin vendor. So monitoring, I think, like really important. Yeah, as I said, it's all visualized by Grafana. They can also like access it. And we had this at the start also in our Helm chart, but we removed it completely because same reason as in the operator pattern, just focus on only one thing, and the Helm chart is only for running a basic store and not like bloating up with like 16 GB of memories, like using a complete Grafana stack in it. S3, this was basically a no-brainer for us. It supports already like backups. You have concurrent read writes, no issues with that. You have like already Shopware support for this. Do the file system abstraction, which calls fly system, if I have this correct. We saw like some plugins still use direct file system access. We get this question like quite a lot. If you want to be compatible with PaaS and also in general with Docker, try to like use the Shopware abstraction layer. That makes way easier. At the start in our Helm chart, we use MinIO. Also, there changed the licensing, like Redis. So we went to RustFS. But also this, we never use RustFS in our system. We just use AWS S3. Same reasons as for AWS RDS, but like cheaper. OpenSearch, we added OpenSearch like recently. They have an own operator, which currently works well. We also made a PR to the operator. They also merged it, which was like really cool. We currently have also an open PR in the deployment helper to support like OpenSearch out of the box. And I swear I will fix this PR. Yeah. So what have we learned? Like Kubernetes is like really powerful. You can like easy scale, and also stateless containers are like really no issue. Currently our nodes run on the spot instances. Like they get like AWS can reclaim them, and then it gets like swapped out without any issues. The downside is if you like have limited knowledge in your team, like then maybe like don't use it. If like somebody said, "Hey, Kubernetes is cool," yeah, tell me why. You should like ask why maybe. And there are like also some hard areas. For example, if you do like networking in production, we use Istio for this with MTLS and networking. We have like some people in our team which are like really good at it and also dedicated to Istio. And they have no problems at all to update production with Istio. Yeah, so this is like also hard areas, I would say. Also zombie node debugging, which Tim mentioned with the kubelet issue. That was like not really a problem, but if you use, for example, AWS EKS out of the box, then you never heard maybe from kubelet. And since we like already have like run an own Kubernetes cluster, so for example, me in my home lab, I know already, hey, there's like a kubelet, we should check the service because he's like responsive to scheduling the pods and stuff like this. So we found it out like really quickly, to be honest. We would do the KDS package meter differently. This is like the Symfony recipe, what I told you. Currently, this prevents us a bit to make like infrastructure updates. So we have Velki Sentinel currently running for the caching. And we needed to do like some URL changes inside the shop configuration. Since we told the customer to use the recipe, they installed the recipe, so they handle the shopper configuration. And then we needed to talk to like 30 customers to tell them, hey, you need to update your package. And that took like a while, so that was like an issue. We want to move this into our build step, so we're also building the images for the customers. So we want to move this in our build step. Therefore, we have like complete control how the infrastructure will be looked or what will be used in the end. But we still need to provide a way to support this for the community. So there's like currently ongoing discussions how we want to solve this. But there will be a way to also maintain this in the future. We would go again with the Shopware Operator. I think that this is like open source is like really strong. We already have like issues, and also some guys already made like PRs. This is like really good. The abstraction layer is also really benefit. So if you have, for example, as I tell you, like with the backup restore, if you want to do it in custom code, we can do it there, and you have like Go, and then you can like write it. You can also do this with a deployment helper, if this is like possible, but currently it's like not done. So this is more a custom lifecycle, so it should go in the operator, but it is not. Also, the deployment helper is like doing the heavy lifting here, so this is like currently also no problem. And maintenance is also not too hard. So if you have like fixes and issues, it's good written, so it's like fine. It's not too hard to understand, like operators in general. Yeah, thank you. This was our talk about like running Shopware in a highly available distributed setup.
All right, thank you so much. Now we have a little Q&A. But before I need to tell the people, so I threw you a little bit of a curveball there because like there is no SSH storefront and there is no arrow building, but both are doing drones and both are doing home automation. You can ask them why later. So there are two guys with microphones. You do this and then they come running. No, don't run. You have a bad knee. Don't make Michael run. Anyway, but I want to start off actually with a question. So there are people in the community who just recently discovered Docker, for example, and now you had a talk that I would summarize as intimidating. Now imagine someone from the community, a developer, is going to the boss, and the boss says, "Kuba, what? Tell me the ROI, please." Why should I use Kubernetes in the first place? Like, does it give me more money? Does it why?
That's a pretty hard question.
Yeah, that's
really hard question. Yeah, Patrick, do you want to answer it or?
Thank you for the curveball.
I can simplify. I can ask what type of agency / store / whatever should actually use this, because like if I have my customers on a shared hoster and doing stuff with FTP, I'm probably not the target group, right?
Yeah. Well, so if you dedicate it to Kubernetes, then I would say like, hey, you should like really make sure, as I said, like if you have like 5 people, we are all trained in Kubernetes. We go to KubeCon, we have like trainings. We already used it before. I used it to get into Shopware, so that was like my CV basically. So you should like have knowledge about this already. If you use like if you mean like only Docker, then Docker is like way easier to understand. It's also already built in Shopware CLI, so you can already like use it today. And like for scaling, if you have like Docker, you can scale like really quickly up. If you use like VMs or somewhere, like you can spawn this, but this will like maybe take time. So
one additional question from my side, then we go through yours. Is there a soft entry into this whole thing, or is it all or nothing?
Soft engineer?
No, soft entry. Like I know, like if I start painting, I don't need to be the greatest painter in the world, right?
If you want to see how Kubernetes like works and also like the scaling stuff and all these kind of things, we have open source the Helm chart. There's also an entry how to like get started with this, and you should like everything gets like copy pasted, and then you have like a running Kubernetes locally on your laptop. And then you can like scale and then like see how fast it is and stuff like this. This is like the entry is there, but if you go into so if you have like multiple customers on like multiple node setup, and then you start like, hey, how to like mitigate that they can talk to each other, then you need to do like networking, and then you start off, okay, I need to switch out the network controller. Like then it gets like more.
Okay, so you start slow locally,
yeah.
And if it's nice, then you go deep into it. Okay, are there questions? Claudia says no. Because there is no time? So sorry. But yeah, you still are available, right?
Yeah, we are sitting down. We have like our own booth dedicated to Shopware PaaS, but you can also like ask me about like controller or Helm charts, or like ask not only me, sorry.
Or in general about Kubernetes.
Yeah.
So
yeah, perfect. So ask them. There will now be a break until 2 p.m. Food is available. And after that, on this stage, there will be a talk about composable commerce projects. So see you then. Have a nice meal.